In last meeting, we have discussed how we can define the shear stress because of torsion. Shear stress is symbolized by tau. It's a tau. Okay? What is the formula of a shear stress? That's the general one. If it is generated by a torsion, the formula of a shear stress will be Tc over J. T is the torque applied to the shaft, and it is the internal torque. Then you need to sectioning the shaft to understand what's torsion generated inside the shaft. Okay? What about C? What is C? C is the radius. C in this book is explaining the maximum radius, but it can always be the radius everywhere inside the shaft if you need to find out what's the shear stress generated somewhere inside the shaft. But mostly we are interested to the torque generated at the most outer, the surface. Why? Yeah, we would like to know the maximum tau, the maximum shearing stress generated in the surface of the shaft, and then we would like to compare it with the allowable stress. If it is less, your shaft is fine. If it is more, your shaft is in danger. It can break, it can crack anytime because it has exceeded the limit, the allowable, the limit of the safety strength. Okay, so that's why Tc over J. Yeah, the J is the polar moment of inertia. Moment of area is the area multiplied by distance. Therefore, it is called a moment of area. The shear stress distribution inside the shaft, maximum at the surface, and then linearly decreasing toward the axis. So in axis there is no stress, it is most relaxing location. Why it is linear? Because it is still in elastic zone. Because in elastic zone the relationship between stress and strain is linear by what we call constant. The constant is called as Young's modulus or elastic modulus. In this case, the elastic modulus is called as shear modulus. Agree?
Yes.
Agree, yeah? What we did was, in order to get delta is the displacement, let me finish this one here. This is by uniaxial load. Okay? Now, delta can be obtained by FLOAE. To FL. LO, and this is the A. Cross section area. Now I move to shear or torsion. Torsion again is sum with tau is equal to G gamma. What is this? Tc over J equal to G gamma. Easily you can get that relationship. Yes, gamma is of course TCJG. But we would like to get twisting angle. We would like to get a twisting angle. Then you need to find what is the formula of gamma. C phi over L. Therefore we get C phi over L. TC over JG. C cancel, L move to the right hand side. Therefore, you can get P phi is equal to TL over JG. Look, this is force, this is length. This is force, this is length. This is area, this is modulus. This is area, this is modulus. Same exact shape. So if you remember this, don't tell me you cannot remember this. Because this is very elementary. Ayo, make your brain work. FL over AE, gimana bisa remember this one? Just a simple derivation. Then how the torsion can be derived? Okay, I don't want to do this one. Just remember that this parameter is represented exactly as it is in this term. Meaning, when it is uniaxial, the force is a force. But when it is a torsion, the force is no longer a force, but it is a torsion. So the F becomes T. The L is the L of the bore, but for this one is the L of the shaft. So it becomes the shaft, the length of the shaft. J and A is equivalent. They are telling the parameter, the dimension parameter. If it has a large A, of course it will also get larger. See? So J and A is a friend. They are the same, but because it is torsion, we cannot use A anymore. We should consider A as a J. In this uniaxial, because the loading mode is uniaxial, so it corresponds to the Young's modulus, because Young's modulus is often from tension, tensile. But because now the load is torsion, E is no longer applicable. It is under shearing, so shear is G. Is it right? Yes. Okay, good. So that's how you remember the relationship between twisting angle and the shaft parameter. Twisting angle, as it goes far away from the clamp, it will get increased, meaning that it is a summation, same as delta. So if you are asked to calculate the twisting angle in the end of A from B, meaning you need to add every twisting angle from each section, because it contributes to the next section. It's just like a spring, like a spring. So you have 3 springs. Why 3 springs? Because that's the way you section, you partition your shaft. Remember what's the rule of partition or sectioning? 1, when you see a new force applied. 2, when you see new area, new dimension. Gampang kan? Now we go to a very common problem in machinery. Okay, you use shaft because you want to transmit torque. That's the only purpose of using shaft. You want to transmit the torque generated by the engine to your machinery. Therefore, your machine will work, right? Sometimes you cannot modify the rotational speed of your engine. It could be an engine, it could be a motor, electric motor. It usually rotating in a certain speed. But you want to control your machine speed, not depending too much with the engine. So you need a shaft transmission. Okay? You have 2 shafts. Okay, you have 2 shafts. you are applying, this is the fixed end, this is the torque you are applying. And you would like to know if you are applying a torque at shaft BE, what would be the torque of shaft AD. Knowing that there are two gears connected with different radius. When two gears in connection, the only parameter that is transmitted the same is the contacting force. The torque cannot be the same. This is why I'm telling you this one. This is the small gear and this is the big gear. Between these two, when they contact, they are sharing the same force. Like I'm shaking Sean's hands. Now I'm pushing, he's pushing. We are having the same force over here. Otherwise, we'll be jumping over. So this is what's static. So the force applied from the small gear to the big gear or the big gear to the small gear should be the same. Should be the same, correct? So this is the force, action and reaction. They are in contact in the gear tools. Okay? This is F and this is F prime. They are the same. Okay? F prime equal to F, of course. Yeah. Now each of these gear has okay. Let's call this as a gear B and this is gear A. This is the radius, we call it at RB, and this is the radius of gear RA. Okay, because F prime is equal to F, F prime is equal to F, and we know that the torque is equal to F times R. Agree?
Yes.
Agree? Okay. Now I can translate this into F prime is equal to torque A times R A equal to torque B times R B. Therefore, if in this problem the input is torque B, you want to get torque A. What would be the torque A if you input torque B? Right? So, torque A is equal to, gitu kan ya? Torque A is equal to RB over RA times TB. So, this is the ratio of gear. Now, tell me, Michelle, which radius should be bigger? Therefore, I can get TA bigger than TB.
Sir, I thought F is supposed to be T over R.
Sorry.
Because it's F over R.
Yeah, thank you for that. F over R equal to T. So, sorry. F equal to F equal to T over R. I'm sorry, thank you. T over R. R. Gini ya? TA over RA, TB over RB. Therefore, it will be twisted. This is R. TA equal to RA over RB. Thank you. This is RA, RB. Back to Michelle. Michelle, you are giving TB, but you want to get TA but larger than TB. How would you do to this ratio? Increase the ratio, of course, right? Increase the ratio. So, how to increase the ratio, Michelle?
Increase the RA.
Increase RA. The bigger RA you have, the larger the diameter of gear A, you will get a larger torque. this is actually like your bicycle, right? In the front, you use the small one. In the back, you use the big one when you in a slope. Remember, when you're riding a slope in bicycle, you put the front one connected to the pedal, the smallest one. But the rear side, you make the bigger one because it creates a larger torque at the wheel rear, the rear wheel. That's what happened. That's similar. So that's what you do. You try to increase RA, therefore larger torque can be generated. Okay. The twisting angle. What's the relationship between twisting angle of these two? What is the same between these two? What is the same when it moves? What are the same? The arc. The arc, the displacement, the arc. The movement between this angle to this next angle. Because it should move together. Right? You should move together. So when you have a point A over here, move to A prime, the location of, or the distance, the traveling distance from A to A prime will be the same as this. Okay? So you know that the arc of gear A and the arc of gear B should be the same. Okay? What is the formula of the arc?
The distance between A and F.
Sorry?
Distance between A and F.
The distance between A and prime is the arc. And what is the formula to get the arc? The radius times angle, correct? The radius times angle. Okay, so what I would like to say is phi A times RA will be the same phi B RB because they are traveling exactly at the same route. When you want to get A, it will be a ratio of RB over RA sigma phi B. This is the ratio. Now look, when it becomes torsion, it is RA over RB. When it becomes twisting angle, it becomes RB over RA.
The torque, we can imagine that we need a bigger radius for the A.
Mhm.
When riding a bicycle, we need a bigger B and the
Yeah.
back for the front.
Yes.
I cannot imagine the twisting angles.
Yeah, if you rotate gear B by, let's say, 30 degree, and you know that gear A is bigger than gear B, the twisting angle at gear A will be bigger or smaller?
Gear B is bigger.
Gear B is having a 30 degree. Okay, and you know that RA is bigger than RB. Therefore, the twisting angle at gear A will be smaller than 30 degree or bigger.
Smaller.
Smaller. So it will rotate a bit.
Yeah.
Let me ask you more. Siapa yang suka modify motorcycle? Pernah nggak lihat di jalan yang suka ngetrail, ban belakangnya dibikin kecil sama dia? Apa tujuannya? Pernah nggak? Road racer, street racer. Pernah nggak ngeliat motornya belakangnya kecil, bannya? Tipis kecil. Kenapa?
More force, 4 times.
Oh, gimana?
Like 4 times distance because of distance and you can say it more
More twisting is here.
more torque.
Last contact surface.
The larger the radius, the larger the torque, gitu ya. The smaller the radius, the smaller the torque, but you get
Twisting is angle.
angle gede. So the traveling of your wheel is more Kalau you make it bigger kayak traktor jangan lambat. Makanya traktor jalannya gede belakangnya, wheelnya gede. Tahu traktor, Adit, Adit? Oh, saya nggak tahu. Saya nggak tahu. Kamu pernah lihat traktor nggak? Di jalan aspal gitu, belakang gede sekali kan bannya? Apa?
Farm.
Ya farm, boleh. Farm juga, belakang masih gede. Kenapa dia nggak perlu ngebut-ngebut? Tapi when you see that street racing yang dikejar polisi itu, ban belakangnya kecil-kecil. They want to have a larger traveling arc. Muter dikit kencok gitu. With the same speed ya, same angle, same speed of engine. Okay. Now this, because we are talking about twisting angle is, you know, like I told you, it is like a spring, a series of spring. It is connected to each other. Okay? When you do this, remember it is like a spring. It's connected to each other. So when you fix this, you don't allow D to rotate. Meaning you fix this, you ground this. Whether you welded this one or you put it in the wall, udah deh, pokoknya fix, no rotation. Then you apply a torque. My question, what would be the twisting angle at E?
Zero.
Zero. How come it becomes zero? The zero one is at D. D is fixed, no rotation at all. And you are applying a torque. My question is, what would be the twisting angle at E?
DL over JG. DL over JG.
That's the general formula, correct, Rafi? Yes, yes. TL over JG is the formula. It's always the formula. Okay? Now, I want you to see this one. From D to A, will point A get twisted?
Yes.
No.
From D to A.
Point A twisted?
Point A di tengah ya?
Point A enggak.
Point A twisted.
No.
Kalau di tengah twisted.
Twisted toh? Yes.
Point S twisted dong. Point A.
Twisted. You rotate this point, the shaft will rotate. As the shaft rotate, the gear B will rotate. As gear B will rotate, it will rotate gear A. Of course, absolutely, at A, the shaft will be rotated, twisted. From D to A, the rotation angle or the twisting angle is TL over G. The T you obtain from here to here, sectioning. The L is this L. The J is the J for this shaft. The G is the material. That is the twisting angle at A. So we call this as this one. It is TADL over JG. And then how can you find the torque of shaft DA from BE? By that relationship, TA equal to RA over RB/TB, and you found that RA is twice big as B, therefore the torque is also twice as big as B. TAD equal to 2T. The L is the L, JG is the same. So this starts phi A can be obtained by this equation. That is the twisting angle at A. Observing that the arcs, CC and CC prime must be equal, as I told you now. This is the relationship. We get that the twisting angle of B is twice as big as A from that relationship. Then you can plug this equation into this. You can find that the twisting angle phi B is 4TLJG. Okay, you have done with this. you done with the relationship, then the rest is from here to there. So you do it like a series, one by one. You find the contribution of each section. This to this, this to this, this to this. Okay? The rest is of course from B to E. From EB. It is TL over JG again. The T is of course the same T because that is the only T applied to the shaft. No gearing transmission. The L is the same JG, and so you get this one. This is the twisting angle from B to E. Now, because from D to A it rotates, from A to B another rotation, from here to here another, so it has like 3 contribution of twisting. So you add all of that one by one. You add the rotation at twisting angle at B with the EB, which is obtained from sigma A, phi A. So the total twisting angle at E is the addition of this parameter and this parameter. You get 5TL over J.
Judging from the equation, this one in the previous yang soal tadi, is a shaft BE is subjected to more torsion.
Shaft?
No, shaft AB is subjected to more torsion than shaft BE.
Shaft AD?
AD is subjected to more torsion than shaft BC.
Yes.
So why would we phi is displacement?
Is twisting angle.
Twisting angle of the displacement of the shaft.
Yes.
So why would shaft AD have less displacement than shaft BE, even though it is subjected to less load?
Because this is near the fix. This is where you fix it. This is where it starts. This is the minimum displacement you have near the wall, and this is the total displacement of everyone. But if you're asking only that, thank you. If you're asking, sir, what if we combine? What if we compare the twisting angle of BE and DA only? That's good. The twisting angle of BE is TL over JG. If the L is the same, J is the same, G is the same, the only determining parameter is the T. Right? If you ask if the configuration is like this, TB and TA, which one is larger? TA. TA is larger. Therefore, 5A larger. So if you are just comparing the twisting angle of DA, BE, yes. Now look at this particular problem. The shaft is connected to a electric motor. It transmits, of course, a torque. The torque is used to rotate the gear A, B, C, D. All of the torque is in counterclockwise positive. Everyone is the same. So if you want to know what is the exerted torque from the electric motor, it will be the total of this torque. 1.2 plus 0.8 plus 0.4. So that's the total torque generated by the engine, by the motor. Okay. Jarvis, can you tell me at which location the twisting angle is the largest? Now, the question more detailed. If you compare the twisting angle between between AB, BC, and CD,
I think it's the same.
no, not the same. How come it's the same?
BC is the biggest.
Itu logika yang nggak kepake. Ayo dipakai dong, pakai. Jangan di sini. Ayo dong. Mikir, ah.
BC dong.
My question again, if you compare the twisting angle between AB, BC, CD, which one is the biggest?
CD.
Torsion dari motornya itu ada bukan?
AB.
Answer. CD is the biggest, you think?
AB. Oh, AB. Kan distance.
Iya.
AB.
AB. Wih, lah. Why AB? Sean, why AB?
Because of the distance.
Diameternya dia.
Stop itu.
Arah torque beda.
Jaraknya sama deh. AB, BC, CD, all have L distance.
Enggak, itu diameternya tuh.
Oh, itu diameter.
Itu diameter bukan distance.
Diameter.
Diameternya.
Itu diameter. Kirain distance. Itu ada tanda panahnya.
Itu bukan diameter.
Diameter.
Tapi Sean nggak salah-salah amat kok jawabannya, karena L itu proporsional kan. Oke. If all of the distance is L between AB, BC, CD gitu ya. This is your shaft. Okay. BCD. BCD. At this one, there is a torque, yeah, at this location.
Itu diameter.
At this one is 1.2, 0.8, and 0.4. This should be in equilibrium. Therefore, is this a reaction force or reaction torque from the motor? Because that's the origin, that's the power, the source of power. So, if the motor should exert
2.4 kiloliter.
yes 2.4 kilo 2.4 kilonewton meter kilonewton meter. Okay. A, B, C, D. Johan, tell me the internal torque of AB.
Baby kan.
Sama Delon, internal torque of AD.
AD
AD. So AD.
2.4. 2.4.
2.4, correct. You have applied 2.4. Of course, the internal torque generated is Michelle. What is the internal torque in BC? Contoh voice. 1.2. What about CD, Raffi? Is 0.4. What about after D? 0. No more. Okay. So TAB is 2.4. TBC is 1.2. TCD is 0.4. My question was, if you compare the twisting angle of section AB, BC, and CD, which one will give you the largest twisting angle? AB dong. Kok bisa sih di Ansel? TL over JG. L the same, J the same, G the same. T is the largest. This is the only contributor. Okay. Then I will ask you, what is the total twisting angle at D?
0. Wait.
At D. Twisting angle at D. How can you obtain?
The sum of the
Twisting angle of AB plus BC plus
CD.
gampang kan?
Okay.
Terus saya iseng nih, saya tambahin di sini gear, pasang lagi ke sini nih, tuh, seger gitu kan. Tarik di sini berapa? Gampang, tanya, oh berapa sir R-nya sir? Kok ngasih soal bercanda gini sih sir, gitu lah. Arya, wake up. Bukan maksudnya nggak berarti nggak tidur, cuman kok dia tadi jawabnya salah gitu. Segampang, pakai SD aja bisa.
Dek, twisting angle-nya gimana deh?
One more deh.
Ya udah, kita cukup.
Thank you.